At 3:22 in the morning, a truck leaves a contract finishing farm in Duplin County, North Carolina. The load is 180 hogs. Each animal weighs between 250 and 280 pounds. The truck runs a GPS-tracked route to a Smithfield Foods processing facility, timed to arrive within a specific window that the plant's kill floor schedule requires. The driver does not set the route. The route was set before the truck departed, but by a logistics system that coordinates the movement of hogs from more than 2,000 contract farms across North Carolina and neighboring states toward processing plants that run 2 shifts, 6 days a week, and cannot afford gaps in supply. By the time this load reaches the plant gate, a dozen other trucks will have arrived before it. Another dozen will follow within the hour. Smithfield Foods operates the largest integrated hog production system in North Carolina, and one of the largest in the world. The system coordinates approximately 2,000 contract finishing farms. It produces and processes roughly 16 million hogs per year. The genetics, the feed, the veterinary protocols, the transportation logistics, and the processing capacity all operate under coordinated management that tracks each animal from the moment of conception to the moment it enters the harvest chain. The scale is not incidental to how the system works. It is the mechanism by which the system works. Every element, the breeding farms, the feed mills, the contract farm network, the transport fleet, the processing plants, is sized and positioned to function as part of a continuous pipeline that does not stop because any single component pauses. Understanding how 16 million hogs move through that pipeline in a single year requires starting where the pipeline starts, with genetics. The commercial hog produced in Smithfield's system is not a random animal. It is the product of a structured breeding program built on several generations of selection for specific economic traits: feed conversion efficiency, lean muscle deposition rate, litter size, and structural soundness that allows the pig to reach market weight without the leg problems that can ground a fast-growing animal before it reaches the processing window. The breeding pyramid that produces commercial hogs has 3 functional tiers. At the top sit the pure genetic lines, the Duroc, Yorkshire, Landrace, and other foundation breeds that carry the genetic traits the commercial animal needs. These pure lines live in company-owned multiplication farms under strict biosecurity. The pigs at this level never go to market. They exist to produce the next generation of breeding stock. The second tier combines pure lines through controlled crosses. A Yorkshire Landrace cross produces the F1 female, sometimes called a commercial gilt, that carries the hybrid vigor of cross-breeding along with the maternal traits that make her productive as a breeding animal: large litters, good milk production, longevity through multiple reproductive cycles. These F1 females move to the third tier of the system, the contract farrowing and breeding farms where they produce the commercial pigs that will eventually reach market weight. The terminal cross at this level introduces a Duroc sire, or a Duroc cross, whose genetics carry the lean muscle growth and feed efficiency that the finished market hog requires. The resulting pigs, 3-way crosses, carry optimized genetics from all 3 foundation breeds. Their growth rate, carcass composition, and feed conversion reflect decades of selective breeding pressure applied at the pure line level and transmitted through the crossbreeding structure. A Smithfield's company-owned breeding operations maintain this genetic pipeline with the same controlled continuity that a seed company maintains in crop genetics. The pure lines are proprietary. The crosses are programmed. The commercial output, the 16 million pigs that move through the system annually, is genetically consistent in ways that allow the nutritional and health protocols to be applied across the full production network without modification for individual animal variation. Farrowing begins the clock. A sow in the Smithfield system delivers an average litter of approximately 11 to 13 live pigs after a gestation period of 114 days, 3 months, 3 weeks, and 3 days, a figure so consistent that it allows farrowing dates to be scheduled with enough precision to coordinate downstream barn space across the contract farm network. The farrowing crate, a steel frame structure that constrains the sow's movement during the period immediately before and after birth, reduces piglet crushing, a leading cause of pre-weaning mortality. The piglets nurse for 18 to 21 days. During this window, they gain weight rapidly from the sow's colostrum and milk, build passive immunity from the antibodies in colostrum, and develop the gut function and thermoregulation capacity they'll need after weaning. The farrowing house maintains temperatures above 85 degrees Fahrenheit to support piglets that cannot yet regulate their own body temperature efficiently. At 18 to 21 days, the piglets are weaned. The sow returns to the breeding barn for her next reproductive cycle. She will be bred again within 5 to 7 days of weaning. The piglets move to a nursery barn, where temperatures remain elevated and rations are formulated specifically for the digestive capabilities of a newly weaned pig. Highly digestible protein sources, supplemental amino acids, added fat for energy density, and palatability-enhancing ingredients that encourage intake at a time when the pig's appetite is suppressed by the stress of weaning and transition. The nursery phase runs approximately 6 to 8 weeks. Pigs enter at 12 to 15 pounds. They leave at 50 to 55 pounds. At that weight, they are ready for the finishing barn. The finishing barn is where the contract farm system becomes the operational core of Smithfield's production model. More than 2,000 contract farms across North Carolina participate in the finishing phase of the system. These farms are owned by individual farm families, the contract growers, who built or converted the barn facilities that Smithfield system specified. A typical finishing contract grower operates 2 to 8 barns, each holding 900 to 1,200 head. Barn dimensions, ventilation specifications, feeding and watering system designs, and waste management infrastructure all meet standards that Smithfield's production team defines. The grower provides the land, the facilities, the labor, and the utilities. Smithfield provides the pigs, the feed, the veterinary services, the production oversight, and a guaranteed payment per pig produced that covers the grower's variable costs and contributes to fixed cost recovery. The grower carries the real estate and the facility debt. Smithfield carries the commodity and biological risk, the feed cost, the pig value, the market price. The contract structure reflects a risk allocation decision made by both parties. Smithfield gains access to finishing capacity distributed across thousands of locations without owning the land or employing the on-site labor directly. The grower gains a guaranteed market for production services and a supply of pigs and inputs without the commodity exposure that independent hog production carries. When corn prices spike or hog prices collapse, cycles that have driven independent hog producers into financial crisis repeatedly over the past 3 decades, the contract grower's income per pig changes less than an independent producer's because the input costs are Smithfield's to bear. This structure, pioneered in North Carolina and then spread across the industry, fundamentally changed who bears risk in pork production. It also fundamentally changed who owns the supply chain. Inside a finishing barn, the environment runs under automated controls that the contract grower monitors but does not manually set from day to day. Ventilation fans cycle on temperature triggers, us maintaining house temperatures within a range that optimizes pig growth and minimizes the respiratory disease pressure that cold, damp, stale air conditions generate. In winter, minimum ventilation rates, the lowest fan speed that maintains adequate air exchange, prevent ammonia buildup without overcooling the building. In summer, maximum ventilation capacity becomes the constraint, with evaporative cooling pads in some barn designs adding additional cooling capacity during heat events. Feed moves from Smithfield-supplied bulk bins into the barns through drop feeders that allow pigs continuous access. Feed conversion in finishing pigs, the pounds of feed consumed per pound of gain, runs between 2.5 and 2.8 to 1 in a well-managed modern finishing barn. A barn of 1,000 pigs entering at 55 pounds and exiting at 270 pounds over 110 to 120 days consumes approximately 600,000 pounds of feed during that cycle. Across 2,000 contract farms, the daily feed demand is enormous. Smithfield's 9 regional feed mills produce the rations that supply this network. Each mill sources commodity ingredients: corn, soybean meal, distillers' dried grains, added fats, vitamin and mineral premixes, manages inventory against delivery schedules, and mixes rations according to formulas adjusted by the central nutritional team. The mill delivers to contract farm bins on a schedule calculated to keep bins from running out without overstocking to the point that feed quality degrades from extended storage. The feed formula changes as pigs move through the finishing period. A pig at 55 pounds has different amino acid requirements than one at 200 pounds. The starting ration contains higher protein, typically 18 to 20% crude protein, to support lean muscle development. The finishing ration in the final weeks before market reduces protein slightly and increases energy density to promote the fat deposition that affects carcass quality and grade. These phase-feeding adjustments reduce cost by not overfeeding expensive protein in periods where the pig's requirement doesn't justify it, and they improve carcass characteristics at harvest. Centralized health monitoring is the nerve system that runs across the 2,000 farm contract network. Smithfield's veterinary services team maintains oversight of flock health across the full production system. Contract growers report mortality and any health concerns through a system that allows regional veterinarians to track patterns across farms in geographic proximity. When a disease challenge appears at one farm, the veterinary team investigates whether neighboring farms are experiencing similar conditions, adjusts preventive treatment protocols if indicated, and coordinates diagnostic testing to identify the pathogen involved. The diseases that move through swine populations can spread through multiple transmission routes: air, water, feed, contact with infected animals, and mechanical transmission via people, equipment, and vehicles moving between farms. A finishing barn that receives pigs from a farrowing operation experiencing a porcine reproductive and respiratory syndrome (PRRS) outbreak may show respiratory disease 2 to 3 weeks after pig placement, by which time the pathogen is already cycling through the barn. Monitoring the health status of the farrowing operations that supply each finishing barn, and adjusting pig placement schedules when health challenges emerge reduces the entry of diseased pigs into the finishing network. Porcine epidemic diarrhea virus, PEDV, demonstrated the vulnerability of large networked hog systems to rapid pathogen spread when it entered the U.S. swine population in 2013. Within a year, PEDV had killed an estimated 7 to 8 million pigs, predominantly pre-weaned piglets, across the country, causing a supply disruption that pushed pork prices sharply higher. The virus moved along the same routes as the pigs themselves: trucks, equipment, people traveling between farms. Smithfield and the broader industry responded with enhanced biosecurity protocols governing truck washing and disinfection, shower in and shower out requirements for people entering sow farms, and sentinel pig monitoring systems that provided early detection before clinical disease became widespread. The biosecurity infrastructure that emerged from the PEDV crisis remains embedded in Smithfield's operating protocols. Trucks transporting pigs between farms pass through designated wash and disinfect stations. Drivers follow protocols governing their movement between loads. Visitors to sow farms and multiplication facilities follow entry and exit procedures that reduce the risk of pathogen introduction. The waste management infrastructure at 2,000 finishing farms spread across North Carolina's coastal plain is the aspect of Smithfield's system that has generated the most sustained legal, regulatory, and community conflict. Each finishing barn houses 900 to 1,200 pigs. Each pig produces approximately 6 pounds of manure and urine daily in liquid form as it moves through the barn's slatted floor system. Waste falls through the slats into a pit beneath the barn floor, where it collects as a liquid slurry. The slurry transfers periodically to outdoor lagoons, earthen impoundments lined with compacted clay, where anaerobic bacteria break the organic material down over time. The lagoon system works as a manure storage and treatment mechanism. Anaerobic digestion in the lagoon reduces the biological oxygen demand of the liquid, kills a portion of the pathogens present in raw manure, and produces a liquid effluent that, when applied to cropland at agronomically appropriate rates, supplies nitrogen, phosphorus, and other nutrients that crops require. The application cycle, storing in the lagoon during wet seasons and applying to fields during dry growing seasons, matches the storage and agronomic windows that the system depends on. The challenges emerge from scale, geography, and the physical characteristics of the lagoon sprayfield system. North Carolina's coastal plain, where the majority of the contract farm network sits, receives high annual rainfall and has a shallow water table. The proximity of lagoons to waterways, The risk of overtopping during hurricane-driven flood events and the spray drift of liquid effluent onto neighboring properties created documented environmental and community health impacts that generated extensive litigation. Multiple lawsuits filed on behalf of neighbors of contract farms in Duplin, Bladen, and other eastern North Carolina counties alleged nuisance impacts, odor, flies, degraded property values, and resulted in jury verdicts and settlements that ran into tens of millions of dollars. The cases focused regulatory and media attention on the lagoon spray field system and the community impacts of concentrating thousands of hog operations in a relatively small geographic area. Smithfield and North Carolina's regulatory agencies have operated under an agreed-upon framework governing the lagoon spray field system since the early 2000s, including provisions for environmental monitoring of lagoons and a commitment to evaluate alternative waste management technologies. The moratorium on new lagoon construction that North Carolina enacted in 1997 capped the expansion of the lagoon sprayfield approach without requiring conversion of existing operations to alternative systems. The environmental monitoring component of the waste management program includes groundwater monitoring wells at farm perimeters, lagoon level sensors, and nutrient management planning that specifies application rates and field setbacks for each participating farm. Compliance documentation flows to the state's Department of Environmental Quality under the National Pollutant Discharge Elimination System, permits that govern confined animal feeding operations. The transportation network that moves 16 million hogs per year from contract farms to processing plants is a logistics operation of significant scale. A GPS-tracked fleet of dedicated livestock transport vehicles runs continuous routes across the contract farm geography. The routing system coordinates pickup schedules that match the contract farm's finishing timelines. When a barn reaches target market weight, the logistics system schedules a pickup within the window that plant kill floor scheduling requires. Arriving too early means pigs that haven't reached target weight, but arriving too late means pigs above weight that yield suboptimal carcass composition and create handling challenges. Market weight in Smithfield system runs approximately 270 to 290 pounds live weight. At those weights, the carcass yields a hot carcass weight of approximately 200 to 215 pounds, which translates to a carcass that falls within the specifications that retail and food service buyers purchase against. Transport stress affects pork quality in measurable ways. Pigs experiencing high physical or psychological stress before harvest accumulate lactic acid in muscle tissue, which interacts with post-harvest muscle chemistry to produce pale, soft, exudative PSE pork, a quality defect visible to consumers as pale, watery-looking meat with reduced water-holding capacity that performs poorly in retail display and food preparation. The transport logistics system addresses this by routing trucks to minimize travel time, loading animals without excessive crowding or rough handling, and scheduling arrivals that allow adequate rest time before harvest. The processing plants themselves maintain lairage, holding pens, where arriving hogs can rest and recover from transport before moving into the harvest sequence. Time in lairage, with access to water and minimal additional stress, allows cortisol and adrenaline levels to normalize and reduces the incidence of PSE pork in the finished product. Thus, the processing facility represents the convergence point of the entire upstream system. A large pork processing plant running 2 shifts, 6 days a week, can harvest and process thousands of hogs per day. The harvest sequence, moving animals from lairage through the harvesting process and into the chilling and fabrication stages, runs continuously during operating hours, and the kill floor schedule determines the truck arrival schedule, the barn weight targets at contract farms, the sow farrowing dates, and ultimately the breeding schedule at the genetic multiplication farms at the top of the system. Everything flows toward the plant. The pipeline is designed to keep the plant running at capacity because fixed costs, facility debt, labor, refrigeration, regulatory compliance continue whether the plant runs at 70% capacity or 100%. The farm network, the feed mills, the veterinary services, and the transport fleet all exist to supply that capacity requirement continuously. Carcass fabrication following harvest produces the full range of pork products that the retail and food service markets require. Loins, hams, shoulders, bellies, each primal cut moves into either further processing or direct sale, depending on the product specification. Some cuts move into further processing facilities that produce cooked and cured products, bacon, ham, sausage, or lunch meats, under Smithfield's brand portfolio. Others move as raw cuts to retail and food service channels. The Smithfield brand and the range of labels under which the company's products appear represent the consumer-facing endpoint of a system that began at the genetic multiplication farm, the vertical integration that runs from genetics through feed production, contract farm coordination, transportation, harvest, and processing means that every element of the cost and quality structure is visible to a single management team, and every inefficiency in any element of the chain affects the system's total economics. The contract farm model that Smithfield pioneered in North Carolina spread across the American pork industry over the subsequent decades, reshaping the geography of hog production in the United States. In 1980, the hog production in the United States was distributed across hundreds of thousands of farms in the Midwest and South, most of them small operations raising a few hundred to a few thousand head per year, alongside other agricultural enterprises. By 2000, the number of hog farms had fallen by more than 70%, while total hog numbers held relatively constant, because the remaining farms were dramatically larger. The concentration accelerated through the 1990s and continued into the 2000s. North Carolina became the second largest hog-producing state in the country during this period, driven specifically by the contract production model that Smithfield and its predecessor companies developed and expanded. Counties that had been primarily tobacco and row crop farming regions converted substantial portions of their agricultural base to hog production under contracts that provided guaranteed income to farm families facing the long decline in tobacco's economic viability. The social and economic transformation this produced in eastern North Carolina was not simple in character. Contract hog farming provided income stability for rural families and counties with limited economic alternatives. It also concentrated the environmental impacts of industrial-scale hog production. The lagoons, the odor, the road traffic from feed and livestock trucks in communities that lack the political and economic leverage to negotiate different terms with the companies driving the expansion. The 2,000 contract farms that supply Smithfield's current North Carolina operation represent the end point of that transformation. The farms exist because the system required them. The system exists because the market demanded low-cost pork at a scale and consistency that only coordinated industrial production could deliver. 16 million hogs per year. The number moves through the system in a continuous flow that the pipeline's logistics make invisible at any single point. At any given moment, some of those 16 million animals are piglets in a farrowing crate in the first days of life. Some are growing through the nursery phase, converting high-quality feed into frame and muscle. Some are in finishing barns across Duplin, Sampson, Wayne, Bladen, and the other eastern counties that hold the contract farm network, moving toward market weight on rations delivered from regional mills. Some are on trucks in the pre-dawn hours, following GPS-optimized routes toward plant gates that will receive them by morning shift. The system runs because the pipeline is full at every stage simultaneously. That is the logic of vertical integration at this scale, not that any single element is dramatically efficient in isolation, but that all the elements run together without the gaps and interruptions that a non-integrated system tolerates. A contract grower in Duplin County turns off the barn lights at 10 in the evening. The ventilation fans continue cycling. The feed drops into the trough on the timer's schedule. At 3:22 in the morning, a truck leaves a neighboring farm, already en route. By the time the grower's boots are back on in the morning, the system has already accounted for another 44,000 hogs processed, 44,000 more in transit, and 44,000 more reaching market weight somewhere in the contract farm network. The pipeline does not wait. If this look at the logistics and infrastructure behind one of the largest integrated pork production systems in the world gave you something to think about, hit the like button and help more people find this kind of deep dive content. Subscribe if you want to keep following stories about the industrial systems that run quietly behind everyday food and commerce. Drop a comment and tell us where you're watching from. The reach of these stories continues to surprise us.